I'm just going to spend a little bit of time going through. My goal is to kind of go through at least like one type of each problem, so we can kind of get some practice on simplifying it and doing all of that. Let's take a look on page 1. Let's take a look at number 3. Want to do number 3? I saw some of you guys working through this one yesterday. And remember, the first thing, we're going to have a lot of factoring to do throughout this review and on the test tomorrow as well. We got to look at each one and we got to decide, can it be factored? So like, for instance, s minus 6 and s plus 5, can those two be factored?
Which one?
S minus 6 or s plus 5? No, those are just binomials, right? There's no GCF, there's nothing we can do to it, it's not DOPS. These two here, so first of all, this one, the first thing we always want to look at, I saw some people trying to do DOPS here, but the first thing we always want to look at is GCF. And out of these two, we can take out an S, okay? Here, there is no GCF, but it's 3 terms, and so this one would be product and sum, okay? So here is kind of what I would do, just more than anything to save yourself some time. Hey. Okay, I'll be right back.
I want to dye my hair, but I don't know where to go to get it done. I get so excited when I do one. Yeah, like I don't know any good ones. You can have my lady do it for sure. Yeah, is she good? I need to get my eyebrows done. They're bad. I don't want anyone saying. They're really not that bad. Yeah, I don't. Yeah. I'm shaving my eyebrows grow back. Yeah, I know. I need to get those eyebrows. Okay, so when are we going? That's happened to me when I've left. What happened to her? She's my favorite ginger. I remember that. Oh, that's so cute. I love that.
Even though I was going to say, home is because my little thing has been
That's how mine is too. I found a guy that's going to buy mine when I buy a new car, so yeah, he's going to pay for $500 for it. It's for a read. No, he's going to use it as a daily driver because he thinks it's
Welcome back, thank you.
So he told me he's paying me like $5,000. So I think
All right, so what I would say, a real quick and easy way of trying to save some time for tomorrow, because some of these are going to take some time to kind of work through. As you simplify everything here, factor it as you rewrite it, okay? And so as I rewrite both of these, we're going to keep, change, flip it, but as I keep, change, flip it, I'm also going to factor it at the same time. I'm going to do 2 steps in one, basically. And so here, what multiplies to get negative 15 and adds to get a positive 2? Okay. And make sure you use the letter S. The variable is going to change from problem to problem. So I know we're in the habit of probably using X most of the time, but each problem is going to have its own variable. And so don't put X plus 5, X minus 3 in there, because this problem is using S's, and that might confuse you if you put X's in there. And then you're going to say, oh, well, it doesn't cross off because it has an X. And then, like I said, we're going to keep, change, flip as we go. And so as I rewrite this, I'm going to go ahead and put the S plus 5 here and put the S minus 6 down here. And remember, with multiplication, we can just make this a big fraction, one big fraction. And then all we're looking at is what can knock out? Well, S minus 3s can disappear. S plus 5s can disappear. And And so what we're left with is an S on top, an S minus 6 on bottom. And can we knock the S's out?
No.
No. So that's my answer. Yeah,
Can you do number 10?
number 10. Yeah, I'm just going to kind of go page by page here. Yep, so when we get there, we'll definitely go through it. All right. Here's one a lot of people asked me about yesterday, and this was a good question to talk about. Let's look at number 7. X minus 2 does not factor. And I know it says state the excluded values, and we're going to do that. But in order to do that, I would probably rather do it out of my factored form than my standard form, where you got the big, long polynomial. So we got to factor x squared minus 4x plus 4. There is no GCF. So once again, it's going to be another product and sum problem. Actually, this one is a perfect square trinomial, but product and sum works also. X minus 2 and x minus 2. Okay. So here, once it's in factored form, for the excluded value, what can x not equal here? 2. Okay. Sometimes these may be different factors, and so then you would have to exclude both of them, but here they're the exact same factors, so x can't be 2 here, x can't be 2 here, so we only have one excluded value. But if these two were different, like if this was x minus 2 and this was x minus 3, then you'd have 2 excluded values. There's going to be times where you have a bunch of excluded values. Now, here's the part where you got to be careful. A couple of things. First of all, I only have one x minus 2 that can cross out. You can't cross the other one off unless I have another x minus 2 up here. Okay? Only one's going to cross off. And then the one that I have left is on bottom, and there's nothing left on top. So what do I got to put on top? You got to put a 1. You got to put something there as like a placeholder. If x minus 2 was on top, then I could just write x minus 2 and I'd be done. I don't have to put 1 on bottom. But if it's on bottom, it's kind of like saying 2 and 1/2. Those are different, right? Where the 2 is at makes a difference. Is it on top? Is it on bottom? So 2 and 1/2 are definitely not the same thing. Same thing here. X minus 2 and 1 over x minus 2 are not the same thing. So got to make sure we're careful with how we do that. Okay, any other questions on page 2? All of those are very, very similar. Just factor and simplify. But you guys are kind of starting to get the hang of how important factoring is to everything that we do here, right? Yeah.
On 8,
Mhm.
there's nothing on the bottom.
Yes, right. And then you don't have, you could put 1 on bottom, but you don't need to. Right, yeah. Hudson?
So for the excluded values,
Yep.
on, you just go through them.
Anything that's on bottom. So if it's on top, we don't care. Because we can't have 0 on bottom, so it's anything that makes the denominator 0. But you don't have to worry about the top. Okay. Anything else on page 2? All right, page 3. This one's number 10. All right, we don't have any plus or minus signs here, okay? And this one, sometimes some of these, you wonder, is there anything else I can do? And I think this is one of those where you're like, it seems like I can do something else. Because this is multiplication, we do not need a common denominator. We only need a common denominator on addition and subtraction. So we're going to multiply straight across here. And on bottom, 5 times 3 is 15. A times a squared is a cubed. Okay, do 8 and 15 reduce? No. If I had like 8 over 16, I could reduce that to be like a half. But 8 over 15 does not reduce. All I have is an a to the third on bottom. There's no a's on top. So this is my answer. That's all you can do. Now, excluded values, what can a not equal here? 0, okay? There is no plus or minus signs here. So if there's no plus or minus signs, we're saying, what can I not take to the third power, or 15 times 0? If there's no plus or minus signs, then your restriction is going to usually be 0. A cannot be 0. Okay, one like number 11, or let's jump down to number 12. Very similar type problems here. Because this is multiplication, then what I would do here is just make this one big fraction. Everything on top versus everything on bottom. Okay? You can only do that on multiplication. You can't do it on any other operation. You can't do it on addition or subtraction or anything like that. Division, we got to keep, change, flip. So all 4 of these operations are a little bit different. But multiplication, I just make one big fraction. The only thing here that can factor is this guy right here. Y squared minus 16. Y squared minus 16 does not have a GCF, but it's 2 terms. Can I do dots to it? Can y squared minus 16 factor? Yeah. What's it going to factor into? Okay. Make sure that we take the square root of it. Okay. A common mistake that I saw on the factoring test last chapter was sometimes we divide by 2. Dividing by 2 and taking the square root are not the same thing. Okay. So in a lot of cases I saw like some people put like 8 and 8. Well, 8 times 8 adds to get 16, but not multiply to get 16. So that's different. We got to take the square root of 16. That's why we call it a perfect square, difference of perfect squares. I'm going to go ahead and cross this off. You can do restrictions right now. And I would probably do restrictions before you start crossing things off. Because once I've crossed it off, then you might forget to add it as a restriction. So in this case, we actually have 2 restrictions. What can I not plug in for y right here? 0. And what about here? 4. Okay. So y cannot be 0 or 4. And then as I start to simplify this, that's why I like to make this one big fraction, because the y minus 4s can disappear. The y's can disappear. And I can do the y's because there's no plus or minus attached to the 3 or to the 4. Okay, so it's just y. And so what I have left up here is I have a 3 and a y plus 4. And on bottom, I have a 4. Can I knock the 4s out? No, because on this one, it's connected with the y. So in order to knock this out, this would have to be a y plus 4 on bottom as well. Okay? So they have to be exactly the same expression in order to knock them out. If it's just 4, I can knock it out. But if it's y plus 4 or y minus 4, it has to be another expression exactly the same in order to knock it out. So this would be as far as we could go. If this would reduce, if like 3 and 4 reduce, I could reduce that. But 3 and 4 does not reduce. So that's where I would leave it. Some people asked me yesterday, do we need to distribute this back through? Not really. Okay. If you did, it's not wrong. Okay. It would just be an extra step that you don't necessarily need to do. I would say just leave it in factored form would be the better way to leave it in most cases. Okay, let's go to page 4. Okay, big difference here. So we've seen some division, we've seen some multiplication. Now this page has addition and subtraction problems on it. Okay, and addition and subtraction are the ones that we have to have a common denominator on. And so the first couple that I gave you are a little bit easier because they already have the common denominator there. If I look at my 2 fractions, they both have the common denominator that we want. And so the first thing that we talked about when we do something like this is just write x minus 10. We know that that denominator will remain the same. It's not going to change. Okay? So we know the denominator will be x minus 10. And then this is kind of where some people were getting thrown off yesterday. This is addition here. So we're going to do 10x plus 9. they're not alike terms, so we can't combine them together. We can't make like 19x because one's an x and one's not an x. So 10x plus 9 is as simplified as that can be. Can I knock out the tens? Nope. Okay, these are different expressions up here. There's nothing to be factored here. So, like I said earlier, sometimes these look like you feel like I got to do more, but that's it. That's all you got to do. And it's fairly simple because you already have a common denominator. So if you already have a common denominator, then life's good, right? It's where you don't have that common denominator that makes it a little bit more difficult. We'll do one of those here in just a second. Okay, let's go look at one that is not common. And not only, so let's do number 18. The first thing that we always want to do on these problems is we want to identify the LCD. Hey, the LCD is the least common denominator, so it's the least thing that both of these go into. So if these were both x plus 4s, we would already have, okay, a common denominator. This denominator has an x plus 4, this one has an x minus 3. Both of those have to be included in our denominator. So my denominator, my LCD here, would be the combination of both of those. X plus 3, or sorry, x minus 3, x plus 4. I got to have both of those for my denominator. Okay, so here's what we decide. This one already has x minus 3, but we need an x plus 4 there. Okay, so when I multiply to change this denominator, I'm going to multiply by it on top and bottom. So I'm going to multiply by x plus 4 on top and bottom. Over here, we already have an x plus 4, but I need an x minus 3. So I'm going to multiply by x minus 3 on top and bottom. Whatever you do to the bottom, you have to do to the top. You got to keep it an equivalent fraction. Like if I have a half, in order to keep it an equivalent fraction, if I multiply by 4 on top, I got to multiply by 4 on bottom, which would give me 4/8. Same thing here, except you're doing it with an expression rather than a number. Okay. What I would do now is this. We know, just to make it a little bit simpler, we now know what the denominator is going to be. Okay, make it one fraction. I think that's going to be the simplest thing to do in most cases is try to make it one fraction when you can. Okay, here when I add or subtract these together, we're going to put it into one big fraction by the very end, and we know what the denominator of that fraction is going to be. That's my LCD. Okay, now we do have a little bit of math to do. Here I have a 5 times an x plus 4. So I got to take 5 and I got to distribute it to that x plus 4. So I would say go ahead and distribute as you go here. Five x plus 20. Hey, the tricky part here that probably gets missed a lot is that this is a minus sign. So kind of an easy way to do this is you could think of this as like a minus 3 or a negative 3. So when I distribute the 3 to include this negative in here, I could go ahead and distribute a negative 3, which I think makes it a little bit easier. So what you could do is you could make this a plus and make that a negative 3. That way you include the negative as you distribute. That way you don't have to do it at the very end. And then we just distribute the negative 3 throughout. And so that would be minus 3x. And then negative 3 times negative 3 would be positive 9. Okay, so I'm just trying to show you some tricks to eliminate like mistakes that you might make with positives and negatives and all of those different things. All right, so we have x plus 4. We have x minus 3. 5x minus 3x would become 2x. 20 plus 9 would be 29. answer. That's all we can do. Okay. Questions on anything there? Okay. Anything else on page 4? You guys-
You do 19 or 20 on those?
Okay, they're going to be very similar. What's going to be the LCD here? Let's do 20. Yep, it's going to be both, right? They're different. So x minus 5, x plus 5 is that LCD. Okay, and I always like to kind of write that to the side, saying this is what we need the denominator to be. This one already has an x minus 5, so what does it need? X plus 5. So we got to multiply by that x plus 5 on top and bottom. This fraction here already has the x plus 5. It's missing the x minus 5. So this one I'm going to multiply by x minus 5 on top and bottom. Okay, once again, when you get to this point here, I like to make it one big fraction. Just to eliminate, if you have two separate fractions, I think it makes it a little bit more confusing. We know the denominator should now be the same, so go ahead and make it the same and make it one fraction. That's our goal anyway. Like when we get done with the one that we did up here, we finished it with just one fraction, right? There's not like two separate fractions that we're adding together because they have a common denominator. We're trying to add or subtract those two fractions together. Okay, so try simplifying the top. See what you can do by simplifying the top. Very similar to what we did on number 18. I will do it as you guys do it and see what we come up with. Okay, anybody brave enough to say what they got on top? Okay, Hudson, is that what you get? Same thing, okay? That's it? Negative 6x plus 10. Okay, now, I did get asked this question yesterday, and it's a good question. Do we have to factor or can we factor the top? We can. Do we have to? Well, here's what I would say. I could take out like a 2 here. And that leaves me negative 3x plus 5. And that replaces that, okay? The only reason why you would have to take out a GCF or factor it in some shape or form is to see if something on bottom is going to disappear. And that could happen in some cases. In this case, negative 3x plus 5 and x plus 5 are not the same thing because this one has a negative 3 in it. So it doesn't really do me a whole lot of good there, but we don't really know that until we factor it. So the only purpose of factoring at that place is to see, could I possibly simplify it a little bit more? And there might be a few times where you could do that. On that one, it does not. So either one of those would be acceptable answers. You could either leave it like negative 6x plus 10, or you could put it in factor form. Both of those would be okay. Okay, the difference here is that this is an equation. We do have a plus sign in here, but we have an equation. And the process that we kind of talked about here is we want to multiply by the LCD. We want to multiply by whatever that LCD is going to be. Over here, it's assumed to be like a 1. So I have an x, and a 1. So out of those three denominators, what would be my LCD? What do x and 1 have in common? 1x, okay? And we do have to include the x in there as well because it is something that is on bottom. Anything that's on bottom has to be included in our LCD. Like if I had a 3 and a 4, my LCD would be 12, okay? Here we have an x and a 1, so 1x or just x would be my LCD. So my LCD here would just be x. So we're going to multiply all three fractions by x. My goal here is to get rid of the fractions. We don't want fractions left. We want to make this a simpler equation to solve, okay? That's our goal. Always try to make things as simple as we can. So we're going to take it one fraction at a time. So if I have x times 7 divided by x, what's going to happen? The x's are going to disappear, right? And all I have left with is 7. X's are gone, okay? And the second fraction, I'm going to do x times 4 divided by x. Well, the x's disappear. So I just have 4 left. Over here, I have negative 2 times x divided by 1, which is negative 2x. Okay? Now, if I ask you to solve this, it should hopefully be pretty easy, right? It's just a single variable. 7 plus 4 is 11. And divide by negative 2. And that's my answer. What I would tell you on number 23, you only have one of these, so I don't want to do it for you because I want you to at least attempt it, but it's the same idea. We have to find the LCD of all 4 fractions. You got 4 fractions, 2 on top, 2 on bottom. And then we have a fraction over a fraction too. But we're going to look at each individual fraction on top and bottom. I have a 3, a b, a 2, and a b. What would be, and also on bottom I have a 4, what would be the LCD of 3, 2, 4, and b? Something they all go into. Okay. 12b. Yep. 3, 2, and 4 all go into 12. Okay. It's the lowest thing they all can go into. So 12b. So we're going to multiply all 4 of those fractions by 12b and then simplify it. All of these should start simplifying as I multiply through. Okay. So give that a shot. Okay, these last two, I'm going to do one of these with you because the restrictions especially are a little bit different here. 25 I think is a little bit harder, so let's take a look at number 25. As I rewrite this, this is a keep, change, flip problem because we have a division sign in between. These can be written a lot of different ways, right? Sometimes we see it as a fraction over a fraction. Here we have a division sign in between 2 fractions. It's the same thing. It's just a little bit different way of writing it. So on the front page we saw it a little bit differently. Here we see it with a division sign in between. But these are still keep, change, flip problems. Anytime you see a fraction divided by a fraction. Now, as I rewrite this, I'm going to factor it as I rewrite it. Just try to make these as simple as you can with the least amount of work that we have to do, okay? The first fraction, I'm keeping it the same, but I want to factor it as I rewrite it, okay? There's no sense in rewriting it and then factoring it, and that would be like an additional step that I don't really think needs to happen. So we got to factor as we go. X squared minus 16 factors into what? Okay. It's adopts, right? X plus 4, X minus 4. And I like to just cross them off as I go, so I know I'm done with that, okay? X squared plus 5x plus 6. It's a trinomial. So what multiplies to get 6 and adds to get 5? 3 and 2. Okay, now remember you're going to flip, okay? And this is the part you got to be really careful of. This is going to move up here, and the bottom's going to move to the, or the top's going to move to the bottom. Okay, so it doesn't really matter which one you do first. So let's say we do this one first. And I'm going to cross this off because we already got that one done. Well, multiplies to get 4 and adds to get 5. 4 and 1. But remember when we rewrite it, we're going to put it on bottom because they got to flip. And then this one is going to move to the top. What multiplies to get negative 8 adds to get negative 2. Negative 4 and 2. Okay, now here's where you got to be careful on your restrictions. Anything that's on bottom at any point in time has to be considered a restriction. So these two are definitely on bottom. Negative 2 and negative 3. These two are definitely on bottom. So those would be negative 4 and negative 1. This was on bottom at one point in time, and it's now on top. Okay, so this is the one a lot of people forget about because it was on bottom to begin with. So now we're going to add a positive 4 and a negative 2 to the mix as well. And those can be listed in any order. You don't have to necessarily put them in order from least to greatest or anything. Notice that negative 2 is a repeat, so you wouldn't necessarily have to list it twice. It's not wrong if you do, but I could just have left this one off since I already had it included earlier. Okay, but if you list it twice, that's okay. So 5 different restrictions that we have there. If it's on bottom at any point in time, we got to restrict it. All right, because this is now a multiplication, we can make this one big fraction. And all we're doing now is, what can I simplify, what can I take out? Well, let's start looking for things that are alike. X plus 4s are gone. X plus 2s are gone. That's it, okay? Both of the x minus 4s are now on top, so you cannot knock them out. It's got to be a 1 on top and 1 on bottom. Okay, there's a couple different ways that you could write your answer here. But because you have 2 x minus 4s, remember you could write that as x minus 4 squared. It's not wrong to write it as x minus 4, and that's totally fine if you write them separately, but that's a little bit easier way of writing it. And then on bottom, I have an x plus 3 and an x plus 1. And that's our answer. The test is going to look very similar to this, but I am going to knock some problems off tomorrow because some of these do take a little bit of time to work through. So we got 25 questions on here. I think I'm going to knock out like 1 of each type. So I think we're going to get it down to about 20 questions, if I remember right. And so it's going to look very, very similar. Okay. Obviously, the factoring, it's going to be different numbers, different factoring. One thing that you might notice on here is there wasn't any. I didn't give you any slide and divide. Okay, so tries to make that should make it a little bit easier. The 2 or 3 main types of factoring are product and sum, DOPS, and then there's a little bit of GCF as well. Okay, but those are the ones you got to be really, really good at.